Let's look at some set operations and examples. First, we need to be familiar with set operations before we start on any examples. We'll take a quick example and see how the set operations work. The first one is the complement of a set. Complement of a set is set of all elements not in the given set. Remember the keyword not. So A contains 1, 2 and 5. The universal set goes from 1 through 6. So what's not in A is 3, 4 and 6. So that's in the complement. Second operation is intersection of two sets. Intersection of two sets. The intersection contains all the elements in both the sets A and B. So if you find any element in A and B, that goes in the intersection. So if you look at A and B, 1 cannot be in the intersection because it's only in one of the sets. 2 is in the intersection, the other element is 5. So those are the elements in A and B. The third set operation is the union of two sets, A union B. Any element in A or B are going to be in the union. For example, 1 is in A, therefore it has to be in the union. 2, 3, 4 and 5, all these elements are in at least one of the sets, so they are going to be in the union. Let's look at an example involving multiple operations. We have A complement union C intersection B complement. We need to do one set operation at a time, and we need to do them in the right order. There could be more than one way of doing them, more than one order of doing them. For example, I can start with taking the complement of A because we already have A. I also can take the C intersection B in the parentheses because I already have B and C sets. What I cannot start with is taking the union because I don't have A complement and I also don't have the other set. I cannot immediately also take the complement of C intersection B because I do not have C intersection B yet. So let's start with taking the complement of A. First of all, let me replace all these sets with labels for the sets with the actual sets. So those are the actual sets. Let's take the complement. So A, D, E, H complement is going to be B, C, F, G. Those are the elements not in A. That's the only operation I did. Rest of the statement is still the same. Next, I can take the intersection. Still I cannot take the union or the complement. So taking the intersection of A, B, C, D and B, C, D, G, H, B, C and D are in both sets, therefore they go in the intersection. Now I am left with two operations, union and a complement. Still cannot take the union because I don't have B, C, D complement. So let's do that first. Complement of B, C, D is A, E, F, G, H. Now finally I can take the union, which gives me the result. Let's look at this example. We need to see if these two sets are equal to each other. Remember, this is different from showing two sets are equal. We don't know whether they are equal or not until we are done, and depending on our result we have to decide that. So the first set is A intersection of B complement intersection C complement of that whole set. So let's try to do one set operation at a time. We need to determine what those set operations are. We'll set up a table. That would be the best way of answering this question. First we start with A, B and C. For the first set, we need to do what's inside the parentheses first. So in the parentheses we have B complement intersection C, two operations, complement and intersection. We have to start with the complement because for the intersection you need B complement. So first B complement. Second, B complement intersection C. Now we can do the intersection. Now we can do the complement outside the parentheses. So we have that entire set created. So with that set done and with A already available, we can do the final set. Now let's move to the second one. First we can do A intersection B. Next we have to do A intersection C complement, and therefore we have to do C complement first, then A intersection C complement. Now we can do the complete set. So we've created a nice order of set operations so that we can do them one at a time. Remember, the rule is whenever you do a set operation, you have to have what you need for that operation. For example, for the first set, A intersection B complement intersection C complement, I cannot start with the intersection immediately after A because the second set is not yet done. So let's go back to filling these regions. So A contains the regions 1, 2, 4 and 5. These are different from elements. They are not elements. They are labels for the regions in each of these sets. B contains regions 2, 3, 5 and 6. C contains regions 4, 5, 6 and 7. So now to take the complement of B, B contains 2, 3, 5 and 6. Therefore the complement is 1, 4, 7 and 8. Now we can take the intersection with C, which gives us 4 and 7. Take the complement of that set, we get 1, 2, 3, 5, 6 and 8. Now we can take A intersection of the set we just created, which gives me 1, 2 and 5. Let's move to the second set. We can start with A intersection B, which gives me 2 and 5. Now C complement, I already have C, therefore we can calculate C complement. Now we can take A intersection C complement, which gives me 1 and 2. Now I can take the union of these two sets, the sets A intersection B and the set A intersection C complement. Union is regions, or rather elements, in at least one of the sets. In this case we are dealing with regions. So these are the regions in the final set. So now if you compare what's in boldface, the first set and the second set, they contain exactly the same regions. Nothing is missing going from one to the other. So the conclusion, these two sets are equal to each other. Again, if you miss at least one of the regions, the two sets are different. They are not equal. And we've done all the work, and we also have written down the conclusion. Remember, conclusion is really important, and showing your work is just as important.